Waec 2020 Chemistry Objective Past Question 4. Which of the following products could be formed during incomplete combustion of a hydrocarbon? So you have three. You have I, carbon, you have hydrogen, and you have carbon 2 oxide, or what is popularly known as carbon monoxide, what is also known as carbon monoxide. So A, I only, B, I and II only, C, I and III only, D, II and III only. That is 2 and 3 only. So what we are looking at here is the incomplete combustion of hydrocarbons. The incomplete combustion of hydrocarbons. Now, in incomplete combustion in general, it occurs when there is combustion, or when combustion takes place. Combustion, also known as burning, takes place in poor supply of oxygen. So when combustion takes place in poor supply of oxygen, the combustion is said to be incomplete. Now in hydrocarbon combustion, incomplete combustion, like we said, you have it burning in poor or limited supply of oxygen, but the products you have are carbon 2 oxide. You also have carbon, which is released as soot, and then you have water. So these are the products of the incomplete combustion of a hydrocarbon. The difference between this and that of complete combustion is that you have, in complete combustion, you have CO2, which is carbon 4 oxide formed, but in incomplete combustion you have carbon 2 oxide, carbon, and water formed. So among the options, you have carbon, which is 1 or I, and you have carbon 2 oxide, which is III 3, and 1 and 3, I and III only, is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 1. Which of the following substances is an example of a fine chemical? A. Sodium hydroxide, B. Hydrochloric acid, C. Ethylene, D. Ammonia. So we're looking at fine chemicals. And fine chemicals are chemicals produced in relatively small amounts and to high degree of purity. Now the opposite of fine chemicals are heavy or bulky chemicals, and these two terms are basically used in industries to describe the type of chemical being produced. So if the chemical is produced in relatively small amounts to high degree of purity, it is known as a fine chemical. And then if it is produced in large amounts and purity is not really important, it is considered a heavy or bulky chemical. Now heavy or bulky chemicals are also used for production of other materials. So they are used in other processes to produce other materials. Now the options given to us: option A, which is sodium hydroxide, NaOH, sodium hydroxide. It is a heavy chemical because it is used in the manufacture or production of other materials, and for sodium hydroxide it is used in the manufacture of soaps. So soap manufacture. Option B, hydrochloric acid, HCl, is also a heavy chemical because it is used in the manufacture of other substances. In this case, it is used in the manufacture of batteries and photo flash bulbs. Option C, ethylene. Ethylene is considered a fine chemical. This is because it is produced in small or manufactured in small amounts to high degree of purity, and it is used as plant growth factor. Now, also note that fine chemicals, examples of fine chemicals are usually drugs. So plant growth factors are more or less it can be classified somewhat as drugs, but for plant use. And lastly, option D, which is ammonia. Ammonia, NH3. Ammonia is also a heavy chemical because it is used in the manufacture of other substances, in this case fertilizers and explosives. So as we have rightly seen, option C, which is ethylene, is a fine chemical. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. I'm going to be answering Waec 2020 Chemistry Objective Past Question 2. The IUPAC name of the compound represented by the structure below is A. 2-chloro-but-1,3-diene, B. but-1,3-chlorodiene, C. 2-chloro-but-diene, D. 3-chloro-but-1,3-diene. So for the purpose of clarity, I will rewrite the structure in the much more standard way. So what you have is this. Okay, have this way. So that is, so the first, this part, this is it. The second carbon, see it here. So the third, this one here, has the Cl attached to it, so hence represented this way. And then you have this. So this is more or less the correct structure, or what this structure is all about. So we're going to be using the rules for naming organic compounds. Naming of organic compounds. And in naming organic compounds, the first thing you do is to find the functional group. So in this case, the functional group is right here, this chlorine atom. So this is our functional group. So after finding where our functional group is, we name, or we number rather, you number the carbon atoms from the carbon atom closest to the functional group. So this is the carbon atom, right, closest to it, to the carbon atom containing the functional group. So this is 1, this is 2, this is 3, and this is 4. Now after doing this, you have 4 carbon atoms. So the first clue is that the name of the compound will have the prefix but. Now another clue is you have 2 double bonds. So the compound will end with diene. That is 2 di, and then in double bond, presence of double bond, showing that it is an alkene. And then the next thing to do will be to properly name it. So you have 1, carbon 1, 2, so carbon 2 is where the functional group is attached to. So 2, the functional group is a chlorine atom, so 2 chloro. Now, like we said, four carbon atoms, so the prefix but, so 2 chloro, but. Now we have 2 double bonds, one at the first carbon, one as carbon 1, and the second one at carbon 3. So but 1 3, carbon 1 carbon 3, and like we said, it will end with diene because of those 2 double bonds, diene. So 2 chloro but 1 3 diene is the IUPAC name of this compound, and that is option A, which is the answer to this question. Thank you, and please subscribe to this channel for more videos and more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 3. Which of the following substances is a polypeptide? A. Starch, B. Glycogen, C. Protein, D. Fat. So what you are looking at here is polypeptide. What is a polypeptide? Now, polypeptides are organic compounds or molecules formed by the linkage of many amino acids linked by peptide bonds. So as far as polypeptides are concerned, you have amino acids. You have amino acids joined together by peptide bonds. So these peptide bonds, this long chain of amino acids linked together by peptide bonds, when you have many of them, you have what is called a polypeptide. Now, starch, which is option A, is what is known as a polysaccharide. It's known as a polysaccharide, and polysaccharides are basically under carbohydrates, where you have many sugar molecules linked together by glycosidic bonds. Option B, which is glycogen, is also another example or another type of a polysaccharide. So it is a carbohydrate and not a polypeptide. Now option C, which is protein, is a polypeptide. Protein is the most popular type or example of polypeptides because proteins are basically made up of amino acids, and these amino acids are linked together by peptide bonds. So you have what is called a polypeptide or polypeptide chains. And then D, which is fats. Fats is basically just solid lipids of animal origin. So that is not linked, or that is not connected to polypeptides. So as we have rightly established, protein is a polypeptide. So option C, which is protein, is the correct answer to this question. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 5. What quantity of electrons is lost when 1 mole of ion 2 ions is oxidized to ion 3 ions? A. 0 mole, B. 1 mole, C. 2 moles, D. 3 moles. So what we are looking at here is oxidation of ion 2 ions to ion 3 ions. Now, ion exists in or exhibits two oxidation numbers or states. So after ion loses electrons, or ion can lose electrons in two ways to exhibit two different oxidation states. So it can have an oxidation number of +2, that is as ion 2 ion, or it can have oxidation state of +3 as ion 3 ion. So this is written as Fe2+, this is written as Fe3+. So given this state, this shows that the ion in ion 2 is left with 2 valence electrons, while this is left with 3 valence electrons. That is based on their structure, their ionic structure. Now, ion 2, which is this, can further be oxidized to ion 3, which is to this state. And how that can happen is if it loses another electron. So ion 2 is formed when the ion atom loses 2 electrons, while ion 3 is formed when the ion atom loses 3 electrons. So in order for this to happen, that is in order for ion 2 to be oxidized to ion 3, what you have looks like this. So you have this reaction, meaning that 1 electron will be lost in order for ion 2 to be oxidized to ion 3. Now, since only 1 electron is lost, it means 1 mole of electron is lost. That is the quantity of electrons lost. Since it's just 1, it is 1 mole, and 1 mole is option B. So option B, 1 mole, is the correct answer to this question. Thank you, and please subscribe to our YouTube channel for more videos and past questions and answers. Chemistry objective past question 6. What is the mass of silver deposited when 24,125 coulomb of electricity is passed through a solution of silver salt? So you have Ag silver 108, 1 Faraday is equal to 96,500 coulombs. A 432 gram, B 108 gram, C 54 gram, D 24 grams. So what we are calculating is mass of silver deposited when you have this electrolytic process, when you have this quantity of electricity passed through a certain solution containing silver salt. So as rightly established here, 1 Faraday is equal to 96,500 coulomb, and basically we can also get, when you have a certain quantity of electricity and you have the amount, the mass it will liberate, you can simply just use relation cross multiplication, that is using another quantity to find the unknown mass. So as it stands, we have the standard procedure, we have the standard liberation, that is 1 Faraday 96,500 coulombs, which is Q1. You have it liberating 108 grams of silver as the standard, and you are also given a second quantity, which is 24,125 coulomb, to find the mass it liberates. So if you put that down, the first quantity 96,500, the standard quantity, will liberate 108 grams. So the second quantity 24,125 will liberate what mass of silver. So if you put that together, cross multiply this, you have the unknown mass equal to 24,125 times 108 divided by 96,500. And if you do this, make this calculation, it will give you 27 grams, and 27 grams is option D, as we have seen, or as we rightly see here. So D, 27 gram, is the mass of silver deposited when this quantity of electricity is passed through a solution of silver salt. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 7. Equal masses of calcium trioxocarbonate 4 were added to dilute hydrochloric acid at the temperature specified. Under which of the following conditions would the reaction be slowest? A. Calcium trioxocarbonate 4 chips at 20 degrees Celsius. B. Calcium trioxocarbonate 4 chips at 40 degrees Celsius. C. Calcium trioxocarbonate 4 powder at 20 degrees Celsius. D. Calcium trioxocarbonate 4 powder at 40 degrees Celsius. So we are looking at one of the reactions of calcium trioxocarbonate 4, which has a chemical formula of CaCO3, calcium trioxocarbonate 4, and one of its reactions is with hydrochloric acid, HCl, to yield calcium chloride, water, and carbon dioxide. Now, this reaction has a certain rate, as with other chemical reactions. It has a rate or a speed at which the reaction takes place. However, there are some things you can do in order to boost the rate or to increase the rate of the reaction, to make the reaction faster. Now, some of those things include increasing temperature, and then another thing could be to increase surface area of the reactants. Increase the surface area of the reactants. So with an increase in temperature, the reaction rate will increase, so it will take place faster, and with an increase in surface area, the speed of the reaction is also likely to increase. Now, with taking a look at the options given to us, you have chips, powder, 20 degrees Celsius, 40 degrees Celsius. So 40 degrees Celsius is a higher temperature than 20 degrees Celsius, and chips have a lower surface area than powder. In other words, powder have greater surface area than the chips. So when you grind calcium trioxocarbonate 4 into powder, you have successfully increased the surface area of calcium trioxocarbonate 4. So as we have seen here, increase in both of those factors will make the rate of the reaction to increase. But we are asked under what condition will the reaction be slowest. So the reaction will be slowest when you have larger surface area, or when you have lower surface area, and also when you have lower temperature, lower surface area and lower temperature. So when the reactants are in chips, the surface area is lower than when it is in powder, and when the temperature is 20 degrees Celsius, the reaction proceeds slower because the temperature is lower than 40 degrees Celsius. So it's safe to say that the slowest condition for the reaction to take place will be when you have the reaction taking place at 20 degrees Celsius, which is the lower temperature, and also when the reactant calcium trioxocarbonate 5 is in chips, which is possessing a lower surface area. So at 20 degrees Celsius and in chips, that is option A, calcium trioxocarbonate 4 chips at the lower temperature, which is 20 degrees Celsius. So option A is the correct answer to this question. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 8. The high solubility of ethanol in water is due to A. Its low boiling point, B. Its low freezing point, C. Its covalent nature, D. Hydrogen bonding. Now, ethanol belongs to the family of organic compounds known as alkanols, and these compounds are known for their OH or hydroxyl functional group. So this is what qualifies ethanol as an alkanol. Now its chemical formula is C2H5OH. So as you can see, you have the OH functional group in the chemical formula of ethanol. Now what OH group does for ethanol and also for all the alkanols is that it makes majority of them highly soluble in water, and this high solubility in water is due to the presence of hydrogen bonds. Now this arises when, or as a result of, the hydroxyl groups can form hydrogen bonds with water molecules. So immediately they are mixed with water, the hydroxyl functional group forms hydrogen bonds with the water, hence enhancing their solubility. That's why ethanol is highly soluble in water. So as we have rightly said, formation of hydrogen bonds or hydrogen bonding, which is option D, is the correct answer to this question. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 9. Which of the following metals react slowly with cold water? A. Calcium, B. Silver, C. Iron, D. Potassium. So what we're looking at here is reaction of metals with cold water, and we're asked which of these metals react slowly with cold water. So different metals have different ways in which they react with cold water. There are three ways in which metals can react with cold water. Metals could react quickly or violently with cold water. They could react slowly, or they could show no reaction. So there are three things that happens when a metal comes in contact with cold water. These are the three likely scenarios. Now option A, which is calcium, it reacts slowly with cold water, and the products of this reaction is calcium hydroxide and hydrogen. So calcium reacts slowly with cold water, which is one of the reactions here. Now option B, silver, does not react with cold water. Iron as well does not react with cold water as well. So silver and iron do not react with cold water. Then potassium reacts rapidly or quickly, which is the first scenario, with cold water. So Silver and iron are lower series metals. So lower series metals do not react with cold water, while the alkali metals, potassium and sodium, they react rapidly with cold water. And as you progress down the electropositive series of metals, the reaction with cold water decreases. So calcium, which is a group 2 metal, reacts slowly with cold water. So option A is calcium. It is the metal that reacts slowly with cold water, and the answer to this question. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 10. Which of the following pairs of properties of alkali metals decreases down the group? A. First ionization energy and reactivity. B. Melting point and atomic radius. C. Reactivity and electronegativity. D. First ionization energy and melting point. So we have properties of alkali metals. The alkali metals are the group 1 metals. That is, those elements, of course, they are metals which have 1 valence electron, that is 1 electron on their outermost shell in terms of their atomic structure. Now, according to the periodic properties, there are certain properties that decrease down the group or increase up the period or up the group rather. So that is what we are looking at here. We are looking at the properties that decrease down the group. So ionization energy is one of the periodic properties that decreases down the group. Now, the ionization energy decreases down the group because as you go down the group, the number of shells increase. So take for example, or you have lithium as the first group 1 metal, the next you have sodium, next you have potassium. So the number of shells of lithium is less than the number of shells of sodium. The number of shells of sodium is less than the number of shells of potassium. So as you go down the group, group 1, the number of shells increase, and as the number of shells increase, the ionization energy, which is the energy required to remove the valence electrons, to ionize it, will also decrease. So ionization energy decreases down the group. Another property is boiling point as well as melting point. Boiling and melting point decrease down the group. You have the melting point of lithium to be 181 degrees Celsius, that of sodium to be 98 degrees Celsius, that of potassium as 64 degrees Celsius, and that of rubidium as 39 degrees Celsius. So you can see that as you progress down the group, group 1, their melting points increase, their boiling points also decrease, as well as their melting point. So melting and boiling points decrease as you progress down the group in group 1, which is the alkali metals. So we have listed 3 characteristics, and amongst them you have first ionization energy, and you also have the melting point. So you have those two in option D. First, ionization energy and the melting point. So option D is the correct answer to this question, as the properties that decrease down the group. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 11. The most suitable process of obtaining water from an aqueous solution of sugar is A. Crystallization, B. Distillation, C. Filtration, D. Decantation. So we're looking at various separation techniques, and we're asked for the one that is most suitable for obtaining water from an aqueous solution of sugar. So in this case, you are trying to obtain the solvent, which is water, from a solution. So let's look at each of these techniques and see which one is most suitable for this procedure. Now, crystallization is used to separate, it's a separation technique used to separate salts, that is solutes, which readily decompose on heating from solution. So when you have a solution of salts which decompose easily or readily on heating, you make use of crystallization to separate that salt from the solution, and it usually involves heating and cooling of the solution, gentle heating and then cooling of the solution. Now option B, which is distillation, is a separation technique used to recover solvent from solution. It involves heating the solution to vaporize and then condensing the solvent. So when you heat the solution such that the solvent vaporizes, you then condense the solvent, and then you've successfully separated it from the solution. Now option C, which is filtration, involves use of a porous material, and an example of this is our filter paper, to separate insoluble particles from a solvent or a liquid. And lastly, option D, which is decantation, used to separate mixture of liquid and solid particles, which separate into layers on standing. Now from this, we're asked for the one that is suitable for separating water, which is a solvent, from solution, and we saw that B, distillation, is used to recover the solvent, which is the liquid part, which is water in this case, from a solution. So it is the most suitable for obtaining water from aqueous solution of sugar, because the sugar solution will be heated till the water vaporizes, and then the water will be condensed and collected. So option B, distillation, is the correct answer to this question. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 12. Group 7 elements in their combined states are called A. Halogens, B. Anions, C. Halides, D. Cations. So we're looking at group 7 elements, group 7 elements, and as the name implies, they are elements in group 7 of the periodic table. Now these elements are highly reactive, and they usually have an state or require just one electron to achieve the octet state. So their number is -1, their valency is -1. Now, but we are asked what these group 7 elements are in their combined states. When they are found in combined states, what are they called? So let's look at each of the definitions of the options to see which of them fits into this description of group 7 elements in their combined states. Now, halogens are basically just the elements in group 7 of the periodic table. So the elements themselves in group 7 of the periodic table are known as halogens, just the elements. Now, anions are basically just negatively charged ions. An example, we have the chloride ion. Now, halides refers to halogens, that is group 7 elements in combined states, i.e., instance example, that is 1 part halogen, the other a less electronegative element. So you have e.g. chlorides, iodides, etc. And lastly, the cations. The cations are positively charged ions, e.g. you have the sodium ion or magnesium ion, etc. So from this definition, or the definitions we have given for the respective options, option C, which is halides, is what we described as halogens, or the group 7 elements in combined states. That is, when they react, when the halogens have reacted with a less electronegative element, they form what are known as halides, that is the halogens in the combined state. So group 7 elements, halogens in the combined states, are known as halides. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 13. When an ionic bond is broken, bonding electrons are A. Shared between participating atoms, B. Gained by the most electropositive atom, C. Gained by the most electronegative atom, D. Lost by both participating atoms. So what we are looking at here is an ionic bond, and an ionic bond is also known as an electrovalent bond. Now it is formed, or it involves the transfer of electrons from one atom, which is usually the metallic atom, to another atom, which is usually the non-metallic atom. Now the bonds formed are known as electrovalent or ionic bonds, and an example is the bond you have in sodium chloride between sodium and chloride. So this is an example of a compound that has electrovalent bonds. Now when the bond is broken, when an ionic bond is broken, what happens is that the most electronegative atom gains the bonding electrons. So for example, you have sodium chloride, the bonds between these two broken. What we have just said is that the most electronegative atom, which in this case is chloride, which is more electronegative, will gain the free electron. So the free electron, which is just one electron from sodium, will be gained by chloride, the chloride ion, or the most electronegative atom, which is the chlorine atom, and it will achieve stability. So this is because the electronegative atom has higher affinity, higher electron affinity. So option C, gained by the most electronegative atom, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 14. The oxidation state of chlorine in NaClO3, which is sodium chlorate, is A plus 1, B plus 3, C plus 5, D plus 6. So we're calculating the oxidation state of chlorine in this compound, sodium chlorate. Now the first thing to understand is that it is a neutral compound, and in neutral compounds all the oxidation numbers add up to 0. So by the time you add oxidation number of sodium, of chlorine, and of oxygen, it's supposed to add up to 0 because it is a neutral compound. Now you know it is a neutral compound because it carries no charge, so it is neutral. Now, so sodium is a group 1 element, so its oxidation number is plus 1. That is the rule for it. And then oxygen, is oxidation number is minus 2, except of course in peroxides and fluorides. That's the only exception where oxygen is not minus 2. So these are rules. Now that we know their oxidation numbers, that is for sodium and for oxygen, we are searching for that of chlorine, so let's call that X. So we substitute our values. Now sodium is 1 plus 1, so 1 plus chlorine, which is unknown to us, X, then minus, that is plus minus, which is minus 2, multiplied by 3 because you have 3 atoms of oxygen, equal to 0. So minus 2 times 3 is minus 6, and 1 plus minus 6 is minus 5. So X minus 5 is equal to 0. So you take this to the other side, X is equal to plus 5. Plus 5, that is chlorine. The oxidation number of chlorine is plus 5, and plus 5 is C. This is the correct answer to this question. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 15. A balanced chemical equation is based on the law of A. Periodicity, B. Constant composition, C. Multiple proportion, D. Conservation of mass. So the concept of writing balanced chemical equation is based on a particular law of is based on a particular law of chemical combination. And basically, the laws of chemical combination are certain laws or principles guiding chemical reactions. So right here we have some laws of chemical combination. So let's see which of them that the law of or the balanced chemical equation is based on. So the law of periodicity, the first thing to note about this is not a law of chemical combination. So the law of periodicity states that the properties of elements are a periodic function of their atomic numbers. Option B, the law of constant composition, is also known as the law of definite proportion, and it states that all pure samples of a particular chemical compound contains similar elements in the same proportion by mass. So that is the law of constant composition or definite proportion. Now option C, the law of multiple proportions, states that if two elements A and B combine to form more than one compound, then the various masses of one element A, which combines separately with a fixed mass of the other element B, are in simple multiple ratio. Then lastly, the law of conservation of mass states that matter is neither created nor destroyed during chemical reactions, but changes from one form to another. So those are the laws given to us. Now, from the statements of the laws we have described here, option D, conservation of mass, accurately describes the reasons why chemical equations are balanced, because a balanced chemical equation depicts the same number of atoms of elements on each side. So if you have 2 atoms on this side, you have 2 atoms on the product side. So the number of atoms on each side of a balanced chemical equation are usually equal or the same, and this is due to the law of conservation of mass, because this shows that no atom or matter was not created or destroyed, but was transformed or was converted from one form to another in the process of the chemical reaction. So option D, the conservation of mass, the law of conservation of mass, is what balanced chemical equation is based on. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 16. Which of the following pairs of elements has the greatest difference in electronegativity? A. Sodium and fluorine. B. Sodium and chlorine. C. Sodium and bromine. D. Sodium and iodine. So we are looking at electronegativity and difference in electronegativity. Now, electronegativity refers to the power of an atom in a molecule to attract electrons. Now, based on the trend, it increases across the period and decreases down the group. So group 1, so take for example, let's say group 1, you have group 1 elements in the group. As you progress down the group, the electronegativity will decrease, and as you go across period 1, the electronegativity will increase. So let's look at each of the values of the elements given to us as the options. Now, sodium has an estimated electronegativity value of 0.9, fluorine has of about 4.0, chlorine of 3.0, bromine of 2.8, and iodine of 2.5. So all we need to do is subtract one from the other, that is, subtract sodium in each of the options from the other elements in order to find the difference in electronegativity, and we'll see the one which has the greatest difference in electronegativity. So for option A, you have sodium and fluorine, that is fluorine 4.0 minus sodium 0.9 equal to 3.1. Option B, sodium and chlorine. Chlorine is 3.0, sodium 0.9 equal to 2.1. Option C, sodium and bromine. Bromine 2.8 minus sodium 0.9 equal to 1.9. And lastly, option D, sodium and iodine. Iodine 2.5 minus sodium 0.9 give you a value of 1.6. So from this you can see that option A, sodium and fluorine, gave us the greatest difference, which is 3.1. So this is the greatest difference in electronegativity. The greatest difference in electronegativity is between sodium and fluorine. Now that is option A. So option A, sodium and fluorine, is the correct answer to this question. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. I'm going to be answering Waec 2020 Chemistry Objective Past Question 17. A factor that is considered most important when siting a chemical industry is A. Nearness to other industrial establishments, B. Nearness to raw materials, C. Favorable climate conditions, D. Availability of storage facilities. So there are various factors that are put into consideration when siting a chemical industry, but we are asked for the one which is considered most important. So let us analyze each of the options to see which of them we can say is the most important. Now option A, which is nearness to other industrial establishments, is not considered very important, as there is no exact benefit associated with siting a chemical industry close to another industrial establishment. So option A is not the answer to this question. Now option B, nearness to raw material, is very important when siting a chemical industry, as this reduces cost of production. Now it reduces cost of production in the sense that the cost of transporting raw materials is reduced. So you don't necessarily have the problem of transporting raw materials from far distances to the industries. So this is safe to say that nearness to raw materials can be considered the most important factor in citing a chemical industry. Now option C, which is favorable climatic condition, is also important in citing a chemical industry. However, it cannot also be considered the most important, as it has no direct effect on production. And option D, availability of storage facilities, is an important factor, but it cannot be considered important in citing the chemical industry. So the one that can be considered most important, as we have rightly established, is option B, the nearness to raw materials. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 18. The boiling point of pentane is higher than that of propane because A, carbon-carbon single bonds are stronger than carbon-hydrogen bonds. B, pentane has more covalent bonds to break. C, pentane does not bond easily as propane. D, the intermolecular forces in pentane are stronger than those of propane. So these two compounds, pentane and propane, are both under the category of organic compounds known as alkanes. And as you may know, alkanes have a general molecular formula of CN H2N plus 1. So in pentane, N is equal to 5, so it has a formula of C5 H, that is 2 times 5, 10 plus 1, 11. Meanwhile, propane, N is equal to, this N is equal to 5, propane N is equal to 3. So you have C3 H, 2 times 3, 6 plus 1, 7. So this is pentane, this is propane. Now we are asked why the boiling point of pentane is higher than that of propane. Now for alkanes and for most organic compounds as well, the boiling point increase down the series. So as you progress down the series, that is from methane to ethane, right, to propane, progressing down the series, the boiling point increases down the series. Now this is due to the fact that you have more carbon atoms in general, or more atoms in general. And when you have more atoms in general, this means that you have more intermolecular interaction. Now more intermolecular attraction means stronger intermolecular forces. So the more the atoms you have, especially carbon atoms, you have more intermolecular reaction, and then you have stronger intermolecular force. Now this stronger intermolecular force determines the boiling point. The degree of intermolecular force determines the boiling point, due to the fact that you would need more temperature to break, or higher temperature to break these intermolecular forces. So the boiling point and other physical properties such as density and melting point arise from the intermolecular force. And option D, we said because the intermolecular forces in pentane are stronger than those of propane. So we have described intermolecular force as what gives rise to boiling point. So the correct answer is D. The intermolecular forces in pentane are stronger than those of propane, and that is the reason why the boiling point of pentane is higher than that of propane. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 19. Which of the following solids would not decompose on heating? A. Ammonium chloride, B. Lead 2-trioxocarbonate 5, C. Potassium trioxocarbonate 4, D. Sodium hydrogen trioxocarbonate 4. So we have some solids here, some of which are salts, and we are asked for the one which does not decompose on heating. So let's look at how each of the salts behave when heated. Now, option A, which is ammonium chloride, it decomposes on heating. So this is ammonium chloride, a solid. When heated, it decomposes into ammonia and hydrogen chloride gas. So you can see here that it decomposes on heating, and hence it's not the answer to this question. Now option B, lead 2-trioxocarbonate 5, it decomposes on heating. Now this is how it works when it's exposed to heat. This is the reaction. So this is the compound lead 2-trioxocarbonate 5, a solid. When it is heated, it decomposes into lead oxide, okay, and oxygen. So as you can see, lead 2-trioxocarbonate 5 decomposes on heating into lead oxide, nitrogen 4 oxide, and oxygen. Now option C, potassium trioxocarbonate 4, does not decompose on heating. It does not decompose on heating. Now this is based on the fact that trioxocarbonate 4 of alkali metals, that is group 1 elements, except for lithium trioxocarbonate 4, do not decompose on heating. So we have seen why this isn't the answer, so we have picked this out as the one that does not decompose. So let's look at option D. Option D is sodium hydrogen trioxocarbonate 4. When it is heated, decomposes to give sodium carbonate, water, and carbon dioxide. So we can see that this decomposes on heating, and it's not the answer to this question. So as we have rightly stated, option C, potassium trioxocarbonate 4, is the solid that does not decompose on heating. Thank you, and please subscribe to this YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 20. The following molecules have double covalent bonds between two atoms except A. Oxygen, B. Carbon 4 oxide, C. Ethene, D. Water. So we are looking at covalent bonds, and of course covalent bonds are formed by sharing of electrons. Sharing of electrons. In other words, there is no transfer of electrons, unlike in electrovalent or ionic bonding. So you have some molecules here that possess covalent bonds, but we're asked which of them have double covalent bonds, or double bond, which is usually represented this way. So double bond between two atoms. So let's look at each of the options. Now, oxygen, an oxygen molecule, of course, is O2, that is made up of two atoms of oxygen. Now, each atom of oxygen has 6 valence electrons. 6 valence electrons. So you have one like this with 1, 2, 3, 4, 5, 6. So you have 6 valence electrons, and then you have another with 6 as well. So 1, 2, 3, 4, 5, 6. So when they combine, they form something like this. They form something of this nature. So you have something like this. Now, they each need 2 electrons to complete the stable state, the stable octet states. So they share 2 electrons. So it looks something like this. You have this one, 1, 2, 3, 4. So the last 6, 1, 2, shares the last 2 with this one, and this one also shares 2, 1, 2 with this. So 1, 2, 3, 4. So what you have here is a double bond. You have double bond because this particular one is sharing 2 electrons with this, and this also is sharing 2 electrons with this other atom. So you have double bond. So this possesses double bond and cannot be the answer to this question, because we are asked which does not possess double bond. Now, option B, which is carbon 4 oxide, is something like this. So it is, you have one carbon atom combining with 2 oxygen atoms. So of course each oxygen atom will have 6 valence electrons, and the carbon atom has 4 valence electrons. So the structure that will be formed looks something like this. You have one of the oxygen this way with 6. So 1, 2, 3, 4, 5, 6. Now that 6 is going to be shared with the carbon atom. The last 2 rather will be shared with the carbon atom. So 2 of those carbon atoms out of the 4, 1, 2 out of the 4 valence electrons of carbon will be shared with one of the oxygen atoms. And similarly on the other side, where you also have another oxygen atom with 6 valence electrons, that is 1, 2, 3, 4, 5, 6. So the remaining 2, remember the carbon has shared 2 of its valence electrons with this oxygen atom. It will share the remaining 2 with these other oxygen atoms. So that's where these 2 double bonds arise. You have 2 double bonds. You have one here and another double bond here. So this possesses double bonds and is not the answer to the question. Now option C, which is ethene, has a structure like this, a rather complex structure like this. This is an ethene molecule. You have a complex structure like this, and looking at this structure, you see that the double bond lies between the carbon atoms, the 2 carbon atoms you have. So the 2 carbon atoms each have 4 valence electrons. So it shares 2 of those valence electrons. This one shares 2 of its valence electrons with this one, so you have the double bond. Then the remaining 2 undergoes other forms of combination with the hydrogen atoms surrounding it. And then lastly, so like we have rightly said, ethane has double bond as we have seen here, and hence is not the answer to this question. However, for a water molecule, what you just have is one hydrogen molecule. You have hydrogen molecule, 2 hydrogen molecules, each with 1 valence electron. And what they do is they share each of these valence electrons with 1 oxygen molecule, with an oxygen molecule. So with that, the oxygen molecule of course contains 6 valence electrons and requires 2 to complete it. So each of the electrons required is gotten from the 2 hydrogen atoms. So you have 2 added to the 6, 1, 2, 3, 4, 5, 6 to form a covalent bond. And as you can rightly see in the water molecule, there is no double bond. So the correct answer is D, water. Water does not have double covalent bonds. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 21. The type of isomerism exhibited by cis and trans isomers is A. Positional, B. Geometrical, C. Functional, D. Optical. So what we are looking at here is isomerism. Isomerism. And isomerism is defined as the existence of 2 or more compounds, and these compounds are known as isomers with the same molecular formula but different molecular structure. So this is what isomerism is all about. So there are various types of isomerisms, and you have them represented here by each option. So let's take a look at what each of the option means and see which one best describes what is given to us in the question. So option A, which is positional isomerism, refers to when compounds have the same carbon skeleton, that is, in terms of their molecular structure, they have the same carbon skeleton and even the same functional group, but the functional group is located in a different location. So different location of functional group. Now option B, geometrical isomerism, refers to the existence of compounds with the same molecular formula but not identical in terms of spatial arrangements of the compound atoms. So you have 2 configurations when discussing these spatial arrangements. You have the cis configuration and the trans configuration. So the cis and trans configuration is basically dependent on whether the some atoms in the compounds are located on the same side, that is cis, or different sides, that is trans. Now option C, which is functional isomerism, is when compounds have the same molecular formula but different functional groups. That is functional isomerism. And lastly, option D, optical isomerism, is when you have different molecular asymmetry, and it has to do with rotation of plane polarized light. So from the definitions we have given, we looked at option B, which is the geometrical isomerism, that talks about spatial arrangements of atoms, that is in the cis and the trans configuration. So cis and trans isomers are found under geometrical isomerism. So geometrical isomerism, option B, is the correct answer to this question. Thank you, and please subscribe to our channel for more videos and past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 22. Which of the following has the lowest boiling point? So you have some compounds here. You have A, butane, B, ethanoic acid, C, water, D, ethanol. So we're asked for which of the following has the lowest boiling point. Now the easiest way, or the best way to solve this question, is to use the rule: the higher the molecular formula, or the molecular mass rather, the higher the molecular mass, the greater the boiling point. So the rule is the higher the molecular mass, the greater the boiling point. So the best way to do this is just to calculate the molecular masses for each of the compounds, and then the one with the greatest molecular mass has the highest boiling point, and likewise the one with the lowest molecular mass has the lowest boiling point. So let's calculate for option A, which is butane, C4H10. So it will be important to note that atomic mass of carbon is 12 approximately, of hydrogen is 1, and of oxygen is 16. So here we are using 12, the 12 for carbon, so 12 multiplied by 4 plus 10 multiplied by 1, that is 10 atoms of hydrogen, and that is equal to 58 gram per mole. Now the next is ethanoic acid, CH3COOH, so 12 times 2 plus 4 times 1, so 12 times 2, 2 carbons, 2 atoms of carbon, 4 times 1, 4 atoms of hydrogen, so 3 and 1 here, and then plus the oxygen, 16 times 2, so you have 2 atoms of oxygen here, so that is equal to 60. Next is water, H2O, that is 1 multiplied by 2 plus 16, and that is equal to 18. And then you have C2H5OH, ethanol, that is 12 multiplied by 2 plus 1 multiplied by 6 plus 1 multiplied by 16 is equal to 46. So looking at each of the answers given to us, water, option C, has the lowest molecular mass, and as it has the lowest molecular mass, it means it has the lowest boiling point. So option C, water, H2O, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 24. Which of the following compounds would release hydrogen when reacted with sodium metal? So you have three compounds here. The first symbol represented here is ethanoic acid. The second here is ethanol, otherwise written as C2H5OH, and then the third one written here is methyl ethanoate. So A 1 only, B 1 and 2 only, C 2 and 3 only, D 1 and 3 only. So let's look at how each of them reacts with sodium metal. Now, number 1, ethanoic acid does react with sodium metal, and when it does, when it reacts with sodium metal, it gives a salt, an ethanoic salt, and hydrogen gas. So this is what the reaction looks like. So you have salt and hydrogen gas. So as you can see here, it releases hydrogen. So 1 is definitely part of the answer. So let's also see how ethanol reacts with sodium. So ethanol, which I will write this way, ethanol also reacts with sodium, and this is what the reaction looks like. So it reacts with 2 moles of sodium to give this compound and hydrogen gas. So hydrogen is also liberated, so 2 ethanol is also part of the answer. Now option 3, methyl ethanoate, is an ester, and esters are not exactly known for their reaction with sodium metal. So from what we've seen here, the correct answer is B, 1 and 2 only. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 25. Which of the following substances is not a reducing agent? A, carbon, B, carbon monoxide or carbon 2 oxide, C, oxygen, D, hydrogen. Now what we're looking at here is reducing agent, and a reducing agent is an element or compound that loses an electron to an electron recipient or electron acceptor in a redox reaction, that is an oxidation reduction chemical reaction. Now a reducing agents become oxidized, that is at the end of the redox reaction, and they in turn reduce the oxidizing agents at the end of the reaction. So examples of reducing agents include sodium, magnesium. In fact, the metals, the alkali metals, are all good reducing agents. Then you have hydrogen, carbon 4 oxide, carbon, etc. So let's look at the options we have. Now we have carbon, which we listed as a good reducing agent. We have carbon oxide, carbon monoxide, which we also listed as a good reducing agent. We also have hydrogen, which we listed as a good reducing agent. Now oxygen is an oxidizing agent. That is, it is an electron acceptor and not an electron donor in a redox reaction. So oxygen C is not a reducing agent. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 26. Which of the following statements is correct for reaction at equilibrium? A. All reactions cease to occur. B. The reaction has gone to completion. C. The rates of the forward and backward reactions are equal. D. The amount of products equals the amount of reactants. So, chemical equilibrium is the concept we are looking at. Chemical equilibrium. And a chemical equilibrium, a reaction, is said to be at equilibrium when there is no observable change in the properties of the system with respect to time. Now, another important thing to note is that in a chemical equilibrium, the forward and backward reactions occur at equal rates, and the concentrations of products and the reactants are constant. So let's say we have a two-way reaction, a reversible reaction this way. These are the reactants and it's reversible, and these are the products. So for this to be considered to be in equilibrium, the rate of the forward reaction, that is A plus B equals to give C plus D, must be equal to the rate of the backward reaction, that is C plus D, to give A plus B. And also the concentration of the reactants and the products, their concentrations must be equal. So as we have seen here, option C says the rates of the forward and backward reactions are equal, and we have discussed that in this explanation we gave, that the forward and the backward reactions occur at equal rates. So that is one of the statements or that describes a chemical equilibrium. Therefore, option C, the rates of the forward and backward reactions are equal, is correct for a reaction at equilibrium. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 27. Which of the following reactions are always exothermic? So you have three reactions listed: 1 neutralization, 2 decomposition, 3 combustion. So A 1 and 2 only, B 1 and 3 only, C 2 and 3 only, D 1, 2 and 3. So the first thing we are looking at here is exothermic reaction, and an exothermic reaction is a chemical reaction in which heat is evolved or given off. So a reaction in which heat is given off or evolved is known as an exothermic reaction. So the question we're asked here is which of these reactions are always exothermic. That is, if we are to give all the examples of each of the reactions, which one will have examples that are always exothermic? So let's look at each of the reactions given to us. So neutralization, on a neutralization reaction, is a reaction between an acid and a base to yield a salt and water only. Now, these reactions are generally, neutralization reactions are generally exothermic. They are generally exothermic. So the second reaction, decomposition reaction, is a reaction that involves the breakdown of a compound into simpler substances. So you have a compound, let's use this template AB, is broken down into these simpler substances. Now, whether a decomposition reaction is exothermic or endothermic depends, because you can have what is called thermal decomposition. And in thermal decomposition, you have to heat whatsoever compound you are trying to break down in order for it to dissociate into the simpler substances. So thermal decomposition involves addition of heat, or where heat has to be added to the reaction, and that type of reaction is known as an endothermic reaction because it involves absorption of heat. So in thermal decomposition, which is a form of decomposition, is not an exothermic reaction. So you can't say that decomposition reactions are always exothermic. So option 2 is out of question. Now, option 3, or the third reaction, is combustion, and it is a high temperature exothermic reaction between a fuel and an oxidant. So an example of an oxidant is atmospheric oxygen, and it produces oxidized gases as the product, and the oxidized gases are often in a mixture, the mixture which we often refer to as smoke. So combustion reaction is basically burning is the same as combustion, and as we have rightly defined, it is an exothermic reaction as it involves liberation of heat in high amounts, and the product of the reaction is mixture of oxidized gases which we refer to as smoke. So as we have rightly established here, the exothermic reactions among the list of reactions given to us are 1, neutralization reaction, which we have seen, and 2, the combustion reaction. So 1 and 3, which is option B, is the correct answer to this question. Thank you, and please subscribe for more videos and more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 28. Which of the following standard conditions is not correct about energy changes? A. Standard temperature is 298 Kelvin. B. Standard pressure is 1 atmosphere. C. Concentration of solution must be 1 mole per dm cube. D. Change in heat, that is enthalpy change at 298 Kelvin, is the activation energy. So this is basically discussing standard conditions of thermodynamics. So thermodynamic standard conditions, and let's look at what the standard conditions for thermodynamics are. So first you have the standard pressure, at 1 atmosphere for thermodynamic standards. And then you have standard concentration in thermodynamics to be 1 mole per dm cube. Now, temperature is not specified for thermodynamic reactions. However, most tables or most materials provided compile data at the temperature 298 Kelvin. So this 298 Kelvin is often regarded as the standard temperature in thermodynamic reactions. So these are the standard conditions when it comes to thermodynamic reactions. So let's look at each of the options and see which one is not correct when it comes to these standard conditions. Now, A, standard temperature is 298 Kelvin. We have rightly established that the 298 Kelvin is often regarded as standard temperature in thermodynamics. So this is correct and hence is not the answer to this question. B, standard pressure is 1 atm, as we have rightly established here. In thermodynamics, pressure is 1 atm, so this is correct and hence cannot be the answer to this question. Now, concentration of solution must be 1 mole per dm cube. Standard concentration we have also seen as 1 mole per dm cube, so this is correct as it relates to thermodynamics, but not correct so it cannot be the answer to this question. And then lastly, you have enthalpy at 298 Kelvin is activation energy. Now, enthalpy at 298 Kelvin is known as standard heat of formation. It's known as standard heat of formation and not activation energy. So it is not correct about energy changes, and hence option D is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 29. If 5.0 cm cube of 0.200 mole per dm cube Na2CO3 was diluted to 250 cm cube solution, what would be the concentration of the resulting solution? A. 0.004 mole per dm cube, B. 0.020 mole per dm cube, C. 0.200 mole per dm cube, D. 0.400 mole per dm cube. So in order to solve this question, you make use of this formula C1V1 is equal to C2V2, which involves you using the initial concentration, that is this 0.200 mole per dm cube, initial volume 5.0 cm cube. Now we are looking for C2, that is the final concentration, and we have the V2, the final volume, as 250 cm cube. So if we use this formula, C2 is equal to 0.200 times 5.0 over 250, and that is equal to 0.004 mole per dm cube. 0.004 mole per dm cube is option A. Option A is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 30. The initial volume and pressure of a given mass of gas is V and 3P. What is its pressure if its volume is increased to 2V at constant temperature? A. 3P, B. 2P, C. 3 over 2P, d 2 over 3 p. So this is Boyle's law. Boyle's law, because in this you are dealing with volume and pressure at constant temperature. So you know that the mathematical expression for Boyle's law is P1 V1 is equal to P2 V2. It shows inverse proportionality between volume and pressure of a mass of gas. So let's substitute the values into this formula. So our P1, which is our initial pressure, is 3P. So P1 is equal to 3P. That is 3P multiplied by V1, initial volume, that is V, is equal to P2, the pressure we are looking for, the final pressure, multiplied by the final volume, which is V2, 2V. So 2V. So solving this cancels out. So P2 is equal to 3P times V over 2V. So V cancels V. So P2 is equal to 3P over 2, or another way to write this is 3 over 2P, and 3 over 2P is option C. So option C, 3 over 2P is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 31. Which volume of oxygen at STP is required to burn completely 7.5 dm cube of methane according to the following equation? So you have the equation of reaction here, the combustion of methane. A, 3.75 dm cube, B, 7.50 dm cube, C, 15.0 dm cube, D, 30.0 dm cube. So we are looking for the volume of oxygen at STP, the volume of oxygen required to burn this volume of methane according to this equation. So the first thing we'll do is to look at methane in this equation. So for methane, the molar volume, 1 mole is equal to 22.4 dm cube. That is standard volume under standard conditions. Now we have to find the number of mole of methane. So x mole is equal to 7.5 dm cube. So we have to find the number of mole of methane that is represented by this particular volume. So this is how we do that. And when you cross multiply, that will be 7.5 divided by 22.4, and that is 0.334 mole. Now from the reaction, 2 mole of oxygen was used. So you can see here 2 mole of oxygen was used to burn this volume of methane, guys. So therefore the number of mole of oxygen required to burn our 0.334 mole of methane is equal to 2 multiplied by 0.334, and that is 0.670. Now back to this our molar volume. Remember, in molar volume, 1 mole is equal to 22.4 dm cube. So if 1 mole is equal to this, what is the equivalence of 0.670 mole in, that is volume, the volume represented by this number of mole? So 0.670 is equal to unknown volume. So again, if you cross multiply, the unknown volume is equal to 0.670 times 22.4 dm cube, and that is approximately 15.0 dm cube. 15.0 dm cube is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 32. When 250 cm³ of a saturated solution of copper 2 tetraoxosulfate 6 at 30 degrees Celsius was evaporated to dryness, 5.0 gram of the salt was obtained. What is the solubility of the salt at 30 degrees Celsius when the molecular mass of CuSO4 copper 2 tetraoxosulfate 6 is equal to 160? A 0.031, B 0.125, C 0.640, D 1.560. So we are looking for solubility, the solubility of this salt copper 2 tetraoxosulfate 6, and we are given some values here which we'll be making use of. We are given the molar mass of the salt, we are given the volume of the solution that was containing the salt, we are also given the mass of the salt that was obtained when it was evaporated to dryness. So the formula we use to calculate this, like solubility, equal to mass over molar mass times 1000 over volume. So the volume is the volume of the solution, and then the mass and molar mass is of the salt. So if we input the values, our mass, like we said, is 5 grams, 5.0 grams. That is 5 over molar mass 160 times 1000 over volume of the solution 250 cm³. So if you compute this, it will give you 0.125 as your answer. 0.125 is option B, so option B is the correct answer to this question. Thank you, and please subscribe to our channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 33. The bond between ammonia and hydrogen ion in the ammonium ion is A. Dative, B. Covalent, C. Hydrogen, D. Electrovalent. So in this ammonium ion that is represented by NH4 with a plus, superscript plus, is the ammonium ion, and it is formed when ammonia, a molecule of ammonia, combines with a hydrogen ion, with one hydrogen ion. So there's a form of bond that exists between this ammonia molecule and this hydrogen ion. So let's find out that bond by looking at each of the options and seeing which one best describes that. So for a dative bond is also known as coordinate covalent bond, and it involves sharing of electrons, just like in the normal or the ordinary covalent bond. However, the electron pair that is shared is donated by one of the participants in the reaction. Now option B, the covalence bond, is a reaction in which there is sharing of a pair of electrons between the two reacting atoms or molecules, as the case may be. Now option C, which is the hydrogen bond, is an intermolecular force which arises when hydrogen is covalently linked when hydrogen is covalently linked to elements such as fluorine, nitrogen, and oxygen. And option D, the electrovalent bond, is a bond which involves the transfer of electrons from one atom, which is usually metallic, to another, which is non-metal. So going back to this reaction or this combination between ammonium and hydrogen ion, the bond involved is a dative bond. It's called a dative bond. Now, this is based on the fact that the ammonia molecule supplies the electron pair that is used in the reaction. So since the ammonium or the ammonia molecule supplies the electrons used in this combination between itself and the hydrogen ion, you can see that it is a dative combination, like we have seen from the definition. So option A, dative bond, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 34. Which of the following oxides has a giant covalent structure? A. Aluminium oxide, B. Sodium oxide, C. Phosphorus pentoxide, D. Silicon 4 oxide. This is silicon 4 oxide. So a giant covalent structure is what we're looking at. A giant covalent structure. And it's a structure that contains many atoms joined to adjacent atoms. Okay, many atoms, each one joined to adjacent atoms by covalent bonds. So the atoms are arranged in giant regular lattices. So let's look at each of the structures of the options given to us and then see which one can be described as a giant covalent structure. Now the first one, option A, aluminium oxide, has a structure which is described as a hexagonal crystal lattice. So that is the best description for the structure of aluminium oxide. Now for sodium oxide, it has a structure which is best described as an anti-fluoride face centered cube. So it has an anti-fluoride face centered cubic structure. Now option C, which is phosphorus pentoxide, P4O10, has a hexagonal lattice structure. And option D, silicon 4 oxide, has a giant tetrahedral structure. And this tetrahedral structure, you have the atoms joined covalently. So as we have rightly expressed, it is option D is a giant tetrahedral structure with covalently bonded atoms. And as we defined for the giant covalent structure, we said it is made up of atoms, many atoms joined together by covalent bonds. Covalent bonds. So from that you can see that option D, which is silicon 4 oxide, is a giant covalent structure, or has a giant covalent structure. So option D, SiO2 silicon 4 oxide, is the correct answer. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 35. Which of the following hydroxide is not readily soluble in water? A. Ammonium hydroxide. B. Calcium hydroxide. C. Sodium hydroxide. D. Potassium hydroxide. So we are looking at various hydroxides, and we are asked for the one which is not readily soluble in water, or for the one that is just slightly soluble in water. Now, there's a general rule guiding hydroxides or solubility of hydroxides in water, and that rule is that the hydroxides of sodium, potassium, and ammonium are very soluble in water. Then the hydroxides of calcium and barium are moderately or slightly soluble in water. And then the hydroxides of all other metals are insoluble in water. So this is the rule to remember that is guiding, or that guides, solubility of hydroxides. Now, looking at the options, we have an ammonium hydroxide here, and we said the hydroxide of ammonium is one of those that is very soluble. So this is not the answer. Option A is not the answer to the question. Now, we said calcium, the hydroxides of calcium, as we have a calcium hydroxide in option B. So hydroxides of calcium and barium are slightly soluble in water. So option B is calcium hydroxide. So this is slightly soluble, and so you can't really say it is readily soluble. So it is not readily soluble in water. So option B, calcium hydroxide, is actually the answer to this question. Now, looking at option C and D, hydroxides of sodium and potassium, as we rightly said, are very soluble. So that is why C and D are not the answer to this question. So like we have rightly seen, option B, calcium hydroxide, is slightly soluble in water, and hence is said to be not readily soluble in water. Thank you, and please subscribe to our channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 36. Which of the following statements about the solubility of a salt is correct? A. A salt whose solubility increases with temperature will not crystallize easily on cooling. B. A salt whose solubility is independent of temperature would normally crystallize out on cooling. C. Crystallization would be efficient in separating out a salt whose solubility increases considerably with temperature. D. Solubility of a solid does not affect its crystallization. So we are looking at solubility of a salt as it relates to crystallization, as it relates to the separation technique called crystallization. And in crystallization, what actually happens is that the solution containing the salt is heated to evaporate part of the solvent. So the solution becomes, well, concentrated. So that is to concentrate the solution. And then on cooling the concentrated solution, crystals of the salt is formed. So it is used to separate salts using this technique. Now, crystallization is known for separating salts that readily decompose on heating. Now, but as it relates to temperature, let's look at each of the options. Now, option A salt whose solubility increases with temperature will not or would not crystallize easily on cooling. Now, this statement is actually incorrect, because a salt, the efficiency in crystallization, in this technique of crystallization, the efficiency in this technique of crystallization is higher when the salt solubility increases with temperature. When the salt solubility increases with temperature. So when the salt solubility increases with temperature, the efficiency of the crystallization is higher. So option A is incorrect. Now, option B, which is a salt whose solubility is independent of temperature, would normally crystallize out on cooling. Now, this statement is also incorrect, because if a salt solubility is independent of temperature, then it cannot even be separated using crystallization. So this statement is incorrect. Now, option C, crystallization would be efficient in separating out a salt whose solubility increases considerably with temperature, is correct. Now, as we have rightly said, efficiency of crystallization is based on the change in salt solubility with increase in temperature. So if a salt solubility increases readily or considerably with temperature, it will be much more efficiently crystallized. So that is what is represented here by option C, and that is why it is correct. So let's look at option D. Solubility of a solid does not affect its crystallization. Now, this option is also wrong, as the whole crystallization separation technique is based on solubility. So as we have rightly established, option C, crystallization would be efficient in separating out a salt whose solubility increases considerably with temperature, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 37. How many moles of H2SO4 tetraoxosulfate 6 acid are there in 50 cm cube of 0.108 moles per dm cube solution of the acid? A. 5.4 times 10. B. 5.4 times 10 raised to power minus 1. C. 5.4 times 10 raised to power minus 2. D. 5.4 times 10 raised to power minus 3. So we have volume given to us as 50 cm cube, and then we have concentration of the acid given to us as 0.108 moles per dm cube, and now we are asked to calculate the number of moles. So when you are given volume and concentration, to get number of moles, all you have to do is volume in dm cube times concentration in moles per dm cube. So this will give you the number of moles of that compound. So in this case, 50 cm cube to dm cube is 50 divided by 1000, then multiply by our concentration is already in moles per dm cube, so multiply by 0.108. So this is essentially 0.05 times 0.108, and if you multiply this, it will give you 5.4 times 10 raised to power minus 3. 5.4 times 10 raised to power minus 3 is option D. So option D is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 38. If 20 cm cube of sodium hydroxide was neutralized by 20 cm cube of 0.01 moles per dm cube tetraoxosulfate 6 acid, what is the concentration of the solution? A 0.010, B 0.020, C 0.100, D 0.150. So this right here is a neutralization reaction. A neutralization reaction involving sodium hydroxide and tetraoxosulfate 6 acid. So we are asked for the concentration of the solution. So let's first of all write the equation of reaction. So the equation of the reaction will involve tetraoxosulfate 6 acid H2SO4 reacting with sodium hydroxide to yield sodium tetraoxosulfate 6, a salt, and water. So this is the reaction. So to balance the reaction, you have 2 moles of this and 2 moles of water. So this is the equation of the reaction. Now the molar ratio of both reactants is 1:2. 1:2, that is the molar ratio. So in order to solve this, we'll use this formula CAVA over CBVB is equal to Na over Nb. So Ca is the concentration of the acid. So concentration of acid is 0.01 moles per dm cube. Va is volume of acid, 20 cm cube. Cb is what we are looking for, unknown. Vb is 20 cm cube. Na is this 1 and Nb is this 2. So if we are going to look for Cb and make it the subject of the formula, what we have is Cb is equal to CAVANB over VBNA. So if we input the values, what we have is 0.01 times 20 times 2 over 20 times 1. And if you compute this, you get 0.020. And 0.020 is option B. So option B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 39. Electrons always occupy the lowest empty energy level is a statement of A. Aufbau's principle, B. Hund's rule, C. Pauli exclusion principle, D. the periodic law. So we have 4 laws or 4 principles amongst the options, and 3 of them, A, B, and C, are rules that or principles that govern electron filling into orbitals. Now, while the 4th one, which is the periodic law, is a law that has to do with the periodic table of elements. So let's look at what each of the law stands for. Now, option A, which is Aufbau's principle, states that electrons enter into orbitals starting at the lowest energy level before filling higher energy level. Now, option B, which is the Hund's rule, states that electrons occupy degenerate orbitals singly before pairing. Now, option C, Pauli's exclusion principle, states that two electrons in the same atomic orbital cannot have the same values for all four quantum numbers. And option D, which is the periodic law, states that the properties of elements are a periodic function of its atomic number. So from the rules and principles and law we have stated, option A, which is Alva's principle, explicitly stated that electrons will first enter into orbitals, starting with the orbitals of the lowest energy level before filling higher ones. And our question says electrons always occupy what? The lowest empty energy level. So that statement is contained in Alva's principle. So option A, which is Alva's principle, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 40. Which of the following metals does not react with water to produce hydrogen? A. Lithium, B. Potassium, C. Sodium, D. Zinc. So we're looking at metals reaction with cold water, or metals reaction with water in general, and we're asked for which one does not react with water to produce hydrogen. So let's take a look at how each of these options respond or react with water. Now, for lithium reacts with water violently to form lithium hydroxide and hydrogen, that is gaseous hydrogen. So as you can see, it reacts with water to form hydrogen. So option B, which is potassium also similarly reacts with water to form potassium hydroxide and hydrogen gas. Now option C, sodium, also reacts with water to form sodium hydroxide and water. Okay. However, option D, which is zinc, zinc does not react with water. It only reacts with steam. And that is when it liberates hydrogen gas. So as you have rightly seen, we are asked which one reacts with water in its liquid state. So zinc does not react with water. So as it does not react with water to produce hydrogen, option D, zinc, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 41. Which of the following arrangements of elements is in decreasing order of electronegativity? So you have various orders. Sodium, option A, sodium, magnesium, aluminium, silicon, phosphorus. B, sodium, aluminium, magnesium, phosphorus, silicon. C, phosphorus, magnesium, sodium, silicon, aluminium. D, phosphorus, silicon, aluminium, magnesium, sodium. So we're asked to arrange in decreasing order of electronegativity, and electronegativity is the power of an atom in a molecule to attract electrons. So electronegativity is much more, or electronegativity is higher in non-metals than the metals, because the non-metals are of course known as electron acceptors, so they have more power to attract the electrons. Now, based on this trend, electronegativity increases across the period and decreases down the group. So on a periodic table, as you progress down the group, the electronegativity will decrease, and as you progress across the period, the electronegativity increases. So this trend also arises from the fact that as you progress across a period, as you progress from one element to another across the period, you move from the metals, right, to the non-metals, to the side of the non-metals. Now, if you are to arrange in decreasing order of electronegativity, that means you have the most electronegative first, all right, the most electronegative element first, and then the least electronegative element last. Okay, so looking at the options, what we have here are period 3 elements. So all we have to do to arrange in decreasing order of electronegativity is to start from the non-metal, right, the non-metal side, and then progress down to the first element in period 3. So if you do that, among the options given to us, the first you have is phosphorus, then followed by silicon, followed by aluminium, then magnesium, and then sodium. So you have elements 11, 12, 13, 14, 15. So you start from 15, right, then to 14, then to 13, then to 12, then to 11. So you can see that phosphorus is the most electronegative, and then sodium is the least electronegative. So the correct answer to this question is D. Phosphorus, silicon, aluminium, magnesium, sodium. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I will be answering Waec 2020 Chemistry Objective Past Question 42. The metallic bond in magnesium is stronger than that in calcium because magnesium has a larger atomic size, B, smaller atomic size, C, greater number of valence electrons, D, lower melting point. So the question is talking about metallic bonds, and it is suggestive of the fact that the metallic bond of magnesium is stronger than the metallic bond you have in calcium. So metallic bonds, let's take a look at what they are. Metallic bonds are formed due to the presence of one or two valence electrons which are loosely bound to the atom and move among the other atoms in the metal. They are mobile, that is, those valence electrons are mobile, and they exert an attractive force on positive ions or protons, which hold the atoms together in a crystal lattice. So what holds the atoms together in crystal lattice are usually the positive ions. Now, there are certain factors that determine the strength of a metallic bond. The first factor is the number of protons. Now, the higher the number of protons, the stronger the bond. This is based on the fact that when you have more protons, the attractive force between those protons and the valence electrons will be much stronger. Hence, the metallic bond itself will be stronger. Secondly, you have the number of the valence electrons. Now, the higher the number of the valence electrons, the stronger the bond as well. The explanation is also similar to that of the protons. So you would have more electrons to form or to exert that attractive force on the protons, hence strengthening the metallic bond itself. And then lastly, you have the size of the atom. Now, the smaller the size of the atom, the stronger the metallic bond. Now, this is due to greater force of attraction between the valence electrons and the protons you may have in the nucleus, as when you have a larger atomic size rather, the electrons are further away from the protons, so the bonds are not as strong as you expect. Now, looking at magnesium and calcium, you would agree that magnesium has a smaller atomic size than calcium. Because calcium has one shell more than magnesium. So the size is larger. So magnesium has a smaller atomic size than calcium. And from what we said that the smaller the atom, the stronger the metallic bond. So it's safe to say the metallic bond in magnesium is stronger than calcium due to the fact that magnesium has a smaller atomic size than calcium. So smaller atomic size is option B. Option B is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 43. Consider the reaction represented by the equation. So you have an equation here with triazonitrate 5 of silver reacting with sodium chloride to give silver chloride and sodium triazonitrate 5. Now, the steps that could be taken to obtain pure dry sample of silver chloride from the mixture include A. Heating to saturation and drying, B. Filtering and evaporation to dryness, C. Filtering, washing and drying, D. Crystallizing and allowing to cool. So silver chloride, as the name implies, is basically the chloride of silver. Now, it is known for its low solubility in water. One of its physical properties, low solubility in water, and it decomposes on heating to silver and chlorine, that is its component. So these are important things to note when you are talking about the preparation or in order to obtain pure dry sample of this compound. Now option A says heating to saturation and drying. Now we said it decomposes on heating, so it's a salt that decomposes on heating and it cannot be subjected to high or heating to saturation and drying, because that would decompose the salt, the silver salt. So heating to saturation and drying is not the answer to this question. Now B, filtering and evaporation to dryness, is also not the answer, because you have evaporation to dryness, and evaporation to dryness will involve heating it to very high temperatures, and we have already said that it decomposes on heating, so you won't obtain a pure sample of it. So filtering and evaporation to dryness is not the answer. Now you have filtering, washing and drying. Now it has low solubility in water, so washing and drying may not be or cannot be seen as the best way to obtain a pure sample of it, pure and dry sample of it. However, crystallizing and allowing to cool is a very good way to obtain a pure and dry sample, as the salt, silver chloride, forms as a precipitate, or it crystallizes. So when you carry out crystallization and you allow it to cool, you have pure and dry samples of the silver chloride. So option D, crystallizing and allowing to cool, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 44. How many electrons does phosphorus ion contain? A 12, B 15, C 16, D 18. So this ion of phosphorus, also known as the phosphate ion, which we have represented to us here, we are asked how many electrons it contains. Now we are given the atomic number and the atomic mass. Now atomic number is equal to the number of protons, and for a neutral atom the number of protons is also equal to the number of electrons. So for an atom of phosphorus, it contains 15 electrons. But now for the phosphate ion, we have these 3 minus here, showing that it has gained 3 electrons. So if you want to know the total number of electrons you have contained in a phosphate ion, all you need to do is to add the atomic number, that is 15, plus 3, and that is 18 electrons. 18 electrons, because it has, as an atom in its atomic state, it has 15 electrons, and then when becoming an ion to attain stability, it gains 3 electrons. So 18 electrons, and 18 electrons here is option D, which is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 45. The atomic number of an atom would be equal to its mass number if it A has a totally filled valence shell, B has a high charge to mass ratio, C does not contain neutrons, D exhibits isotopy. So we are asked when or in what condition would the atomic number of an atom be equal to its mass number. Now the mass number of an atom is equal to the number of protons plus the number of neutrons, and then the atomic number is the number of protons. So the condition for the mass number to be equal to the atomic number is if this other factor in the other factor you consider in mass number, which is number of neutrons, is absent. So the only condition where atomic number will be equal to mass number is if the atom does not contain neutrons. So as we have seen, does not contain neutrons is option C. So option C, does not contain neutrons, is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 46. Which of the following processes is not exhibited by atoms in order to attain more stable electron configuration? A. Gaining of electrons. B. Hybridization of orbitals. C. Losing electrons. D. Sharing electrons. So now we are looking at various processes that atoms go through in order to attain stable electronic configuration. So let's take a look at what each of the options entail. Now, option A, which is gaining of electrons, is seen in atoms of non-metals. Now, in atoms of non-metals, they lose electrons. They gain electrons rather. They gain electrons to attain stable duplet or octet state. The duplet state is usually seen in the K shell, and then the octet state is seen in the other LM and shells. So the duplet state is attained when the maximum number of electrons is 2, and then octet is when the maximum number of electrons is 8. So atoms of nonmetals gain electrons to complete this configuration. Now, option B, which is hybridization of orbitals. Hybridization of orbitals is the combination of a given number of orbitals in an atom to produce the same number of new orbitals that are different in shape, and the purpose is that for them to be better disposed for chemical bonding. Now, option C, which is losing electrons, is seen in atoms of metals. Now, atoms of metals, they lose electrons, usually in chemical reactions, to gain stability. That is the same octet or duplet state that we saw in non-metals. Now, option D, which is sharing electrons, is seen in atoms that usually undergo covalent bonding. In covalent bonding, the atoms share electrons to attain stability. So what we have seen is that option A, C, and D are done for the purpose of attaining stable configuration or attaining stability. But option B, which is hybridization of orbitals, is not done for the purpose of attaining electron configuration stability. It is done just to better dispose, or to make the atoms better disposed or in better shape and form for chemical bonding. So hybridization of orbitals is not done for the purpose of stability, but rather to improve the form of the atom for chemical bonding. So option B, hybridization of orbitals, is not a process exhibited by atoms for stable electronic configuration. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 47. Which of the following quantities is a molar quantity? A. Molarity, B. Molar mass, C. Mass concentration, D. Molality. So, molar quantities or a molar quantity is used to express an extensive quantity as its actual value divided by the amount of substance in moles. So a molar quantity is when you divide any quantity by the amount of substance in mole. So any quantity that involves you dividing a particular value or a particular measure of a value, let's say like volume or amount of heat, by number of moles, that quantity is said to be expressed as a molar quantity. Now let's take a look at each of the options and see which one has that description. Now option A, which is molarity, is the number of moles of solute per dm cube or liter of the solution, and this is expressed in moles per dm cube or moles per liter. Option B, which is molar mass, is the mass of a sample of a compound divided by the amount of substance in that sample. Now the amount of substance is measured in mole, and the unit for molar mass is grams per mole. Option C, mass concentration, is the ratio of mass of a solute, the ratio of the mass of a solute present in a solution to the volume of the solution, and its unit is grams per dm cube. And then option D, molality, is the number of moles of solute per kg, per kilogram of solvent, and that is measured in moles per kg. Now, as we've rightly seen, we talked about molar quantity as any quantity expressed by dividing the original value of that quantity by the amount of substance in mole. And among the options we have seen, only option B, which is molar mass, involves dividing a quantity, dividing a value which is the value of mass of a sample by the amount of substance of that sample, that is mole, so grams per mole. So the correct answer is option B, molar mass. Molar mass is a molar quantity. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 48. Dilution factor is the A, amount of distilled water that is added to the concentrated solution to dilute it. B, quantity of distilled water added to 1 dm cube of the concentrated solution to give the dilute solution. C, number of times the volume of the concentrated solution is diluted to give the dilute solution. D, act of diluting the concentrated solution to obtain the dilute solution. So for a standard definition of dilution factor as it relates to solubility and formation of solutions, dilution factor refers to the ratio between the volume of the concentrated solution to the volume of the dilute solution. So this means that if you have two solutions, let's say the volume of the concentrated solution is 20 dm cube, and then the volume of the dilute solution is 40 dm cube. What we are saying is that dilution factor is the ratio between the volume of the concentrated solution to that of the dilute solution. So in this case it will be 1:2. Now it means that the volume of the dilute solution is 2 times the volume of the concentrated solution in this example. So from this description you can say the dilution factor is the number of times, as we have seen here, the number of times the concentrated solution is diluted to give the dilute solution. Now the dilution factor is not a volume. The dilution factor is not a volume, so it is not the amount of water. That is why A is not the answer. It is not the quantity of water as well. That's why B is not the answer. And it is not the act of diluting the concentrated solution. That's why D is not the answer. So the answer is C. The number of times the volume of the concentrated solution is diluted to give the dilute solution. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Welcome, I'm going to be answering Waec 2020 Chemistry Objective Past Question 49. Calcium chloride is an ionic compound. Which of the following statements accounts for its ionic character? So you have 1, 2, 3, 4. 1. Calcium has high ionization energy. 2. Calcium has low ionization energy. 3. Chlorine has high electron affinity. 4. Chlorine has high ionization energy. So A, 1 and 2 only. B, 1, 2 and 4 only. C, 2, 3 and 4 only. D, 1, 2, 3 and 4. So calcium chloride, the compound calcium chloride, that is CaCl2, is an ionic compound, and an ionic compound is a compound composed of ions held together by electrostatic forces called ionic bonds. So usually you have the compound neutral, but in its formation the two atoms involved in its formation are ionized in its formation, forming ionic bonds. So this ionization occurs based on some characteristics of the participating atoms, in the periodic table. So let's look at how it works. Now 1 and 2 talks about ionization energy, and ionization energy refers to the energy required to remove an electron from an atom, specifically each atom in a mole of a gaseous atom. And then you have electron affinity, also talked about in number 3. And electron affinity has to do with the energy released when a gaseous atom gains an electron to form a negative ion. So from these definitions we have seen, other important things to note is that calcium has a low ionization energy, because you require less energy to remove an electron from calcium. Calcium has only 2 valence electrons, so you require less energy to remove the valence electrons. But chlorine, on the other hand, has high ionization energy. Okay, it has 6 valence electrons, so you would require more energy to remove those valence electrons. So talking about electron affinity, chlorine has high electron affinity as it deals with gains of electrons. So this ionic property, the ionic character of calcium chloride, as we have stated, is accounted for by the low ionization energy of calcium, the high ionization energy of chlorine, and the high electron affinity of chlorine. So that is 2, 3, and 4. And 2, 3, and 4 only is option C. So option C is the correct answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers. Hello and welcome. I'm going to be answering Waec 2020 Chemistry Objective Past Question 50. An example of a biodegradable pollutant is A. Plastic, B. Sewage, C. Carbon dioxide or carbon monoxide, D. Hydrogen sulfide. So we're looking at biodegradable pollutant, and a biodegradable pollutant is a pollutant that is a substance that causes pollution that can be broken down into natural components that do not harm the environment over time. And examples of biodegradable pollutants usually include human waste, that is sewage, and also animal waste, and also any other pollutants which can be broken down into natural components that do not harm the environment over time. Now, plastic is not biodegradable as can be broken down into natural components, so plastic is not the answer. Sewage, like we have rightly mentioned, is a biodegradable pollutant, as over time it can be broken down by the action of microorganisms, especially in the soil, that will break the sewage down into smaller natural components like nitrogenous compounds that can increase soil fertility. So sewage is an example of a biodegradable pollutant. Now, carbon monoxide is not a biodegradable pollutant. It's an air pollutant. It's an air pollutant that also causes atmospheric problems in the ozone layer. And then hydrogen sulfide as well is also another gas which is not a biodegradable pollutant, similar to carbon monoxide. So as we have rightly established, option B, which is sewage, is the answer to this question. Thank you, and please subscribe to this channel for more videos and for more past questions and answers.